Hello and welcome to How Do I BI, a mini-part screencast series on SQL Server Analysis Services 2008, based on my book Smart Business Intelligence Solutions with Microsoft SQL Server 2008. I'm Lynn Langett. I'm a developer evangelist in Southern California with Microsoft. In this edition, we're going to take a look at two of the included data mining algorithms in Analysis Services, the association rules, and sequence clustering algorithms. Before we do that, we'll talk about frequently asked questions and gotchas around the implementation of these particular algorithms. As with all data mining models in BIDS, I highly recommend, particularly if you're new to data mining, that you extensively look at the included viewers so that you can understand the functionality of the particular algorithm and select and configure the correct algorithm for your particular business problem. In this case, we're going to be looking at the AdventureWorks included samples, the one named Market Basket for association rules, and sequence clustering is named sequence clustering. Particular to these algorithms, you need to understand which content types are required, and we'll see this in the screencast. Key and key sequence are important in the implementation of these two algorithms. Also, for these two algorithms, you'll need to understand and configure properly the idea of a case and a nested input table for your mining structure and then your subsequent mining models. You can also use advanced parameters. In this case, one that I frequently will use for Market Basket is the size of the produced result or the item set grouping size, and I'll show you in the screencast how you configure that. So now let's go ahead and go over to the screencast. We're going to look at the implementation of a couple of the included data mining algorithms in Analysis Services. In order to do that, I've opened BIDS and loaded AdventureWorks and opened two of the included mining structures with the samples, and those are Market Basket and sequence clustering. So first we're going to start with Market Basket, which is going to show us the association rules mining model algorithm. Before we do that though, I'm going to show you the mining structure. But first, in case you didn't see the previous screencast on how to create a mining structure, I'll show you just quickly that, like anything else in BIDS, you simply right-click on the folder of interest, in this case Mining Structures in Solution Explorer, expose the context-sensitive menu, and click then on New Mining Structure, which will open up the wizard, and click Next. Then select your source data, which can be either relational or multidimensional from cubes or relational data sources, and we'll say relational. And then you select your algorithm. In this case, because we're looking at sequence clustering and association rules, we're going to select association rules first and then click Next. Then we'll select the data source that's included in this project, AdventureWorks DW, and then we'll have to select both a case and a nested table for both of these algorithms. And it's very, very important that these are selected in the correct order or the algorithm won't work correctly. You can go back and adjust this if need be in this wizard, but it's very important to do so. Might be a little bit confusing because it's a new concept, and I think a better way to understand it, I'm going to cancel out of here, is to look at these two mining structures that are actually built with case and nested tables. So in the case of Market Basket, let's begin with the end in mind. What we're doing here is we're using the association rules algorithm to predict which items tend to be sold together. It's the classic, it's called beer and diapers example, where you're discovering patterns in the data of purchasing, in this case, that you wouldn't expect. So which items are together. So let's look first at how we've modeled this. We have two source tables. We have the view, of course, associated sequence line items and the sequence orders. And we can right-click on the sequence orders here and see that the data that's contained by clicking on Explore Data is simply the order number, the customer key, the region, and the income group. So that's the source data that we're interested in. And this is associated to, and this would be the case table, the detailed information, which is the sequence line items. And we'll right-click and explore the data here. And we'll see that we've got the order number, the line number, and the model. Now, a couple of things in the column usage in the mining structure. When we click on order number and we go over to the properties, if we scroll up, we'll see that this has been marked as the key column. If we then go into the model source column and we scroll up, this has also been marked as a key column. So this is establishing the relationship, the order number, between the case and the nested table. And then we simply want to take a look at the model. In the implementation of association rules, when we click on the Mining Models tab, we'll see that the order number has been set up as key, and then we'll see a little plus under the structure for the view, and this is indicating that this is nested and that the model has been set up as a key as well. So if you then take a look at the mining model viewer, you can see, as this is a rendering here, that the association viewer is set up to the association rules viewer. We have that, or the generic content tree viewer, and we can look at the rules, which shows how items are associated, and I'm going to simplify the view to show only the attribute name. And then we can look at the item sets. And this is what I said in the introduction. This is showing which items are sold with which other items. Now by default, it's just grouping to 1. We might want to adjust the maximum item set size view parameter here. I'll put it to 3, for example. And then I'll also change the view a little bit, make it a little simpler, change the show value to show the attribute name only, so it's a little clearer. And now we can see item sets, 3 items that were sold together. So we can see, for example, the mountain bottle cage, so on and so forth, the mountain bike and the water bottle were sold together, and how many cases. The last viewer is also interesting to look at, the dependency network viewer. Again, if we click on a particular node in here, and then we maximize it so we can see, let's pick the mountain bottle, or the water bottle. Let's pick the water bottle and see, and then let's adjust the layout so that we can see it a little bit better and see which items are dependent on the water bottle. So if we drag the dependency slider to the left to show stronger links, we'll then eventually be able to see which other items are more closely associated with the sale of the water bottle. So you can get an understanding of the implementation of association rules by taking a look at the viewer and also taking a look at the structure. Now, another algorithm which functions similarly is sequence clustering. So we're going to open up the sequence clustering and take a look at that, and you'll see that we have similar source data, and that it's 2 relational tables that are related to one another. In fact, they are the same tables. We have the sequence orders. If we explore it, we can see that we have the order number, customer key, region, and income group, just like we had for the previous one, and the sequence line items, which is the nested table, or the detail table, if you want to think of it that way. Oops, want to go back and explore the data here rather than the data source view. And you can see now we've got the order number, the line number. Now, an important difference is in this mining structure, in addition to the order number, which is marked as a key content type, we now are including the line number. And if we scroll up in the properties, we'll see that this is marked as a key sequence. So a difference in the algorithm implementation between the previous one and this one is that when we look at the mining model that's set up for sequence clustering, again, we see the nested value, but notice line number is set up for key. So the results are going to not only show correlated items, but they're going to show the sequence in which they were accessed, or in this case, purchased. And this has several business applications, whether it's a click-through and click-stream analysis for navigating around a website, or items that were purchased one after another, so on and so forth. So if we click on the mining model viewer, we're going to see, once this renders, this is taking a minute to render, that I've set this up to show a new viewer called the state transition. What this is showing is, and again, we've selected the water bottle here, is which items are sold in which order related to the water bottle. So you can see that the road bottle cage is sold first, but prior to that, we have the bike. So you buy your bike, Road 750, then you buy your road bottle cage, and then you buy your water bottle, and it's purchased in that order. Again, we have the ability to adjust the relevancy by clicking on the slider on the left side. And then the last thing that I wanted to point out, and I'm going to go back to Market Basket for this, is if I click on the Mining Models tab under the Association section, and then go over to the Properties and scroll up, then if you click on the algorithm parameters property, that'll open up a build box. Again, it's not really intuitive, so I want to make sure to show this. And this is one that I've actually used in production in terms of viewing and even adjusting the algorithm parameters. You can see inside of here, you can have the ability to look at the default values as well as change them around several important properties in the creation of item sets. You can see, for example, the maximum item set size is set by default to 3, and you might want to adjust that for your particular business needs. So with that, that is these two algorithms in Business Intelligence Development Studio for SSAS.